Tennessee's at-home learning series for math. Today's lesson is for all fifth graders out there, though all students are more than welcome to tune in. This is the 16th lesson in our series. My name is Miss Williamson and I'm a fifth grade teacher in Tennessee School. I am so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find them at the Tennessee Department of Education website, www.tn.gov/education. You can still tune into today's lesson if you haven't seen the others, but you may find it more fun to go back and watch the other lessons first, as we'll be discussing some things we've learned previously. Today, we'll be learning about unit cubes in order to understand the concept of volume measurement. Before we get started, to fully participate in our lesson, you will need paper, pencil, a surface to write on, or you can also have the student packet for lesson 16, grade 5 math found at www.tn.gov/education. I'll give you a moment to get your things gathered. Okay, let's begin. Does anybody recall the name of this figure, this solid figure? You're right, it's a cube. Another name for a cube is a rectangular prism. Some examples of rectangular prisms are tissue boxes. Oh, can't see that under the tissue boxes. Ziploc baggie boxes. These right here are also examples of rectangular prisms. Notice that a rectangular prism has 6 faces, 1, 2, 3, 4, 5, 6, and 12 edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we wanted to measure the space of one of those faces, what would we be measuring? Yes, we'd be measuring area. When we find area, we use square units to determine the amount of surface covered, which is area. Area is measured in square units. Let me show you a square unit. See there? A square unit. If we wanted to measure the space inside of our rectangular prism, so let me rephrase. If we wanted to just know how much space was on the face, I can measure these in square units. I would see how many squares fit on there versus finding the space inside. Does anybody know what we would be measuring when we find the space inside that figure? We would be measuring volume. Volume is measured in cubic units. Cubic units. So here's a cubic unit. Here is a square unit. How are the square unit and the cubic unit similar? I heard they both have the dimensions length and width. Length, width, length, width. So what does the unit cube have that the square unit does not? You're right, it has a third dimension. It has a height. Let me turn it to the side so you can see that a little bit better. So our cubic unit has 1, 2, 3 dimensions, whereas our square unit only has 2. Great observations. So we know a unit cube has 3 dimensions. Look here at this diagram, okay? This is a unit cube. Here is what we discussed about our edge. Here's what we discussed about the face. Now, this unit cube has a length a width, and a height. So it has 3 dimensions. All right. So looking at this unit cube, I could say the length, the width, and the height of this unit cube is 1 cubic unit. They're all 1. Now, what happens when we stack some unit cubes? So let me say I have 8 unit cubes here. I have 8 unit cubes here. And let me make a solid with these 8 unit cubes. And I want to make a rectangular prism. Remember, rectangular prisms are like boxes, like our Kleenex box, our Ziploc box, could even be a shoe box. So let's say I want to make a rectangular prism out of my unit cubes. How could I arrange these unit cubes to make a rectangular prism? You're right. I could arrange them in a row like so. And I would say that this prism is made up of how many? That's right. It's 8 units long, or it's made up of 8 cubic units. What about if I arrange them in 2 rows of 4, like so? Did I create a rectangular prism? I did. What if instead of having it flat, I picked up one of the rows and I stacked them? Is that still a rectangular prism? You're right, it sure is. Can you think of another way I could arrange my 8 cubic units or my 8 cubes to make a rectangular prism? Did you say something about changing the orientation or the way it's stacked? So instead of having this sideways, I could pick up the whole prism and stack it up. Yes, that's a great suggestion. Very creative. Very creative suggestion. Now, what happens if I arrange my unit cubes with a row of 5 and then a row of 3 stacked on top? I'm going to show you that from the top, and then let me turn it over and I'm going to show you it from the side. Now, think about what you saw from the top. Think about what you see from the side with those unit cubes in that formation. Would we call this, or would this make a rectangular prism? No, why not? Oh, of course, because rectangular prisms have to have the same number of unit cubes in each row. Otherwise, it isn't a rectangular prism. So what I could do is I could move this one here. Do you agree? Would that make it a rectangular prism? It sure would. Or what happens if I just add 2 more to make an equal row? Now do we have another rectangular prism? We sure do. Great observation. Now I want you to look at another example of a rectangular prism. In this drawing, I can tell that this figure has 3 dimensions. Do you see them? It has a length, a width, and a height. If I wanted to recreate this prism, so if I wanted to build it, how many unit cubes do you think I would need to build this prism? Did you say 12? You are right. I would need 12 unit cubes to make this rectangular prism. I can count each of the cubes in a row, even though I can't actually see all 6 faces of the unit cubes. So I know that there are 1, 2, 3, 4 cubes in this row, even though I can't see the back. And I know there are 1, 2, 3, 4 cubes in this row. And I know there are 1, 2, 3, 4 cubes in this row. And that tells me I would need 12 unit cubes to make this rectangular prism. Great job, great work. Now let's look at another one. Looking at this rectangular prism, what are some things that you notice? Okay, good work. I love it. Well, I noticed that while I can see three of the faces, one, two, three, some of the faces are hidden from my view. I can't see the bottom, I can't see the back side, and I can't see this side over here. Now, even though I can't see them, I can visualize and know that a rectangular prism is made of equal rows. And so I know these unit cubes are stacked on top of each other without any gaps. So can you tell me how many unit cubes I would need to recreate this prism? Did you say I would need 24 unit cubes? Well, let's check. 1, 2, 3, 4, 5, 6, 7, 8. But I know that there is another row behind it that has how many? You're right, 8. So I'm going to count those again. 9, 10, 11, 12, 13, 14, 15, 16. And I know that there's another row behind that one. 19, 20, 21, I'm sorry, 16, 17, 18, 19, 20, 21, 22, 23, 24. So if you said 24, you were right. I would need 24 unit cubes to recreate or build this rectangular prism. Looking at this image, if I wanted to recreate this next solid figure, I'd want to know how many unit cubes I need. First, let's make a prediction. Can you jot down your prediction? How many unit cubes do you think it would take to make this prism? Now let's look at the figure. What did you say? How many unit cubes did you think? Good guess. Let's find out. To find out, I will have to count each of the unit cubes, though I can't actually see the entire cube. So let's count the number of unit cubes. 1, 2, 3, 4, 5, 6, 7, 8. And in the back, 9, 10, 11, 12, 13, 14, 15, 16. I counted 16 unit cubes. Now, what you want to be cautious of is sometimes we want to count the faces, not the cubes. Well, keep in mind that this, I counted when I put a dot on this cube, if I count this or this again, that's the same cube. Remember, if I were to stack that in there, would I be able to see those faces? I would, but I'm not counting the faces. I'm counting the number of unit cubes. All right, so let's see if we can solve this problem here. Using our visual, what is the length of this prism? Yes, the length is 1, 2, 3, 4, 5, 6, 7, 8. It's made up of 8 unit cubes. The width is 1, 2. It goes back 2 unit cubes. What about the height? Height is usually, we think of height from top to bottom. I notice that there's only 1 cube from top to bottom. So my height is 1. And we already decided by counting our cubes that this was made up of how many unit cubes? That's right. We said our prism was made up of 16 unit cubes. So we would say the length of this prism is 8, the width of this prism is 2, and the height of this prism is 1. And how did we do that? That's right, we counted how many unit cubes. Good job. Let's try another one. Do you recall what we call this figure? That's right, it is called a rectangular prism. If I want to recreate this rectangular prism, I would need to know how many unit cubes it is made up of. Let's start by counting the cubes. Remember, we have to think about the cubes we can't see as well as the ones that we can. So before I know I can see the whole front, I know I could see the whole top. So let's do this time. Let's start with the top. I see 1, 2, 3, 4, 5, 6 cubes that make up the top. And there's another layer underneath that, which would have to have 6 cubes. We know that those cubes can't be floating, so there has to be something under there holding it. So we know below the top layer, there's 6 more cubes. So what would we say about this rectangular prism? Yes, we would say the number of unit cubes used to build this rectangular prism would be 12. How come I didn't say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16? Why did I not say 16? You guys are catching on so quick. You're right, I didn't say 16 because when I counted these more than once, because I was counting the number of faces I see, not the number of unit cubes I see. Remember, volume is how many cubes make up the figure. All right, so let's look at the length. Let's find the length. 1, 2, 3. It is 3 unit cubes from side to side. What about the width? 1, 2 unit cubes front to back. And what about the height from top to bottom? That's right, 2 units from top to bottom. The height is 2. Let's think about how a square unit, remember the square unit? Let me show you that again. Let's think about how the square unit is the same as the unit cube. You're right, they both have 2 dimensions. Square unit has a length, cubic unit has a length. Square unit has a width, cubic unit has a width. But a unit cube also has a, did you say height? That is absolutely right. It has a third dimension, and that third dimension is height. And that's why I say a unit cube has a length, a width, and a height, and so it has a volume of 1 cubic unit. Now let's look at some more examples together. I want you to make sure you're doing this on your paper with me, please. To make it easier, instead of writing out length, you might just write L, W, and H on your paper. All right. Let's start by finding out how many total unit cubes make up this figure. Can you do that? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did you say that 12 unit cubes make up this figure? But wait, we just did another example and we said this one was made up of 12. How can both figures be made up of the same number of unit cubes but look so different? I think we should keep that in mind as we answer the rest of our questions. So what is the length of this rectangular prism? Count with me. 1, 2, 3, 4. This rectangular prism is 4 units long. What about the width? 1 unit long. And what about 1 unit wide? What about the height? 1, 2, 3, 3 units high. Let's think back to the noticings we just made. Did you come up with a conclusion about how both figures could be made up of the same number of unit cubes, yet look quite different? What was your thinking? Oh, good connection. I like the way you're thinking. Although the two rectangular prisms are made up of the same number of cubes, their lengths, their widths, and their heights are different. And so basically, they rearranged 12 cubes into two different rectangular prisms. You guys are picking up on this really quickly. I'm so proud of you. Here's a similar problem to work along with me. First, let's count and see how many cubes would be needed to recreate or build this rectangular prism. Remember, some of the cubes are hidden from our view. Which cubes can we see? Interesting, you're right. We can see the front, we can see one of the sides, and we can see the top. But the cubes that are here have to be supported by the cubes that are under it or behind it that are hidden, so we know they're there. So when determining the number of unit cubes that make up the figure, we can't forget to count the cubes we can't see. And remember, we're counting the cubes, not the faces. All right, are you ready to check yourself? Did you say that this rectangular prism was made up of 1, 2, 3, 4, 5, 6 unit cubes in the front layer and 6 unit cubes in the second layer for a total of 12 unit cubes in all? Fabulous. What did you say the length of the rectangular prism was? Count with me. 1, 2. The length of our rectangular prism is 2 unit cubes. What about the width? 1, 2. Excellent work. And what about the height from top to bottom? 1, 2, 3. Now, do you notice that this prism and this prism and this prism all have a volume or are made up of 12 unit cubes, even though they look different? Remember, that's possible because we're rearranging the cubes, and so the lengths, the widths, and the heights are different, but they are made up of the same number of unit cubes. Now it's your turn to solve one on your own. After a few minutes of work, we'll come back together and check it. Are you ready? Great. Here's your problem. Take about 30 more seconds. Are you ready for us to check your work? Great, let's go. All right, did you add up all the unit cubes? Did you even remember to count the ones that are hidden from our view? Yes, there were unit cubes that were hidden from our view. Remember, we can see the front, we can see the side, one of the sides, and we can see the top. And so we need to remember that even though we can't see all of them, there's more there than we can see. So did you count them up? Help me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes in our front layer and 9 cubes in our back layer for a total of 18 unit cubes. Did you get 18 unit cubes in all? Excellent work. Now, when you identified the length, did you say that it was 1, 2, 3 units long? What about the width? Did you say that it was 2 unit cubes wide? And the height, how many unit cubes high did you say? Good job. You're right. It is 1, 2, 3 unit cubes high. Great work, everyone. Let's try one more on our own. Are you ready? Begin. Take about 30 more seconds. You're doing so great. I'm proud of your hard work today. All right. Did you remember to count all the unit cubes, even considering the ones that were hidden? Great. You'll notice that I always start with one of the sides that I can see all the unit cubes on. For this one, that could be your front, your top, or even your side. I know that the side layer is made up of 4 unit cubes. 1, 2, 3, 4. And I know that that is stacked sideways. And so there's 4 in that layer, and 4 in that layer, and 4 in that layer to give me 16 unit cubes. Remember, we have to be cautious to count our cubes and not the faces of the cubes. Now, is that the only way we could have solved that problem? You're right. I could have said, okay, my top layer has 1, 2, 3, 4, 5, 6, 7, 8, and the top layer is stacked up twice, also giving me 16 unit cubes. And so, how many unit cubes is this prism made up of? That's right, it's made up of 16 unit cubes. What about when you identified the length of the prism? What did you say? Did you say it was 1, 2, 3, 4 unit cubes long? Good job. What about when you went for the width? Did you say it was 1, 2 unit cubes wide? And the height is 1, 2 unit cubes tall. Excellent work. Boys and girls, you did great work today. Remember, we reviewed what the meaning of a unit cube was and a rectangular prism. I hope you're seeing some connections between length, width, and height and its measurement to find the number of unit cubes in a solid figure. You did a great job. After the video, you will have some problems to practice on your own. I will show you your independent practice now. You can also find this practice in the student practice section for this lesson posted at www.tn.gov/education. Good luck. I know you will do your best. I have really enjoyed reviewing unit cubes to mentally construct solid figures, focusing on understanding what a unit cube is and how it has a length, width, and height. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in the Tennessee at Home series. Bye, friends.